Hello, welcome to this physics tutorial. I am Effiong Fortune. In this video, we are going to look at the concepts of scalars and vectors, right? If you've not watched our previous video on physical quantities and units, please do so. I feel it will be best you watch it before watching this video on concept of scalars and vectors. In our study of physics, there are certain physical quantities that are completely described when only their magnitude or sizes are known. We already talked about what physical quantities are. Now, such physical quantities are known as scalar quantities. So by definition, scalar quantities, these are physical quantities that have magnitude but no direction. So underline it, they are physical quantities in the first place and they have magnitude but no direction, right? So scalar quantities are quantities that can be completely described when only their magnitude. They can be completely described when only their magnitude is given. We'll appreciate this more as we go further. In comparison, vectors or vector quantities on the other hand are not completely described unless their magnitude and direction are specified. Vector quantities are not completely described unless their magnitude and direction are specified. Let us use this analogy to explain. Imagine you were inside your house. Let this be the diagram of your house. This is your house. This is your house, the door. Your house. So imagine you were inside. This is you inside your house, and a friend called you. Your friend, let your friend name be Fortune. Your friend Fortune called you. So Fortune called you and said that he is 150 meters from your house without specifying a given direction. So Fortune is calling you inside your from with a cell phone and telling you that he is 150 meters from your house. Fortune says this is 150 meters from your house. So what Fortune has done now, what he has done is that he has succeeded in telling you his distance from your house. However, it will be difficult. It will be difficult to locate Fortune because a direction has not been specified, right? So the best and precise way you could locate Fortune easily, what I mean is that since the direction has not been specified, if he says it's 150 meters, it could be 150 meters north, could be 150 meters west, it could be 150 meters east, it could be 150 meters south, right? It could even be 150 meters northeast. So a given or a specific direction has not been specified. So coming out from your house, it will be difficult for you to, pinpoint exactly where Fortune is. So the best and precise way you could locate Fortune is to ask of his displacement. Now, displacement is distance in a specified direction. And in our previous videos, we had really explained the difference between distance and displacement. So displacement is distance in a specified direction. So when Fortune says 150 meters northeast, so this is more of a specified distance, right? He has specified the distance as 150 meters and he has specified the direction northeast. So he is now giving you his displacement. So when you're coming in, when you're coming out, you're not just moving 150 meters anywhere, you're moving 150 meters northeast. So what this means is that for vector quantities to make sense, both magnitude is the same thing as numerical value. So this 150 is the magnitude. So both magnitude and direction must be specified for a vector quantity to make sense. Whereas for a scalar quantity, it's enough to just give the numerical value. So you could say magnitude or numerical value. So it's enough to just give the numerical value and it will make sense. So now vector quantities, as I said, will always need both magnitude. They need two things, M and D. You could remember, M and D, they will need M and D, both magnitude or numerical value and direction to make sense. Now let's look at the examples of scalars and vector quantities. Example of scalar and vector quantities. Now this table shows scalar and vector quantities. We have scalar by my left and vector quantities by my right. So the first scalar quantity we are looking at here is length or distance. So I said earlier in previous videos that length and distance can be used interchangeably, right? So length or distance is a scalar quantity, meaning that if you're measuring the length of my trouser, it's just enough for you to say it is 50 inches. You don't need to specify whether it is 50 inches to the west or 50 inches to the right or 50 inches to the left, right? But when you are saying that you are, now let's look at the vector quantity displacement, right? If you are saying you are displacing my book 5 meters, it's not enough. You will have to tell me if you are displacing it 5 meters to the east, let's say to the right. Let's use right and left this time. You will have to tell me if you are displacing my book 5 meters to the right, or you are displacing my book, or this book. This is the book. You have to tell me if you are displacing, if you are pushing it 5 meters to the right, or you are pushing it 5 meters to the left. So that's the difference between distance and displacement. So other examples of scalar quantities: energy, acceleration, time, momentum, mass, weight. So just look at this, mass and weight. So initially what we knew when we were growing up is we thought mass and weight were the same thing, but as we progressed, we later realized that there are differences between mass and weight, and one of those differences is that mass is a scalar quantity, weight is a vector quantity. So we have volume as a scalar quantity, and we have force as a vector quantity. Density, scalar quantity. Electric field is a scalar quantity. Now this speed is a scalar quantity. Vector is velocity is a vector quantity. So these are two other quantities. These are two other physical quantities that we are so used to using them interchangeably, right? So sometimes we could say speed, we could say velocity. At times we don't really know the difference between speed and velocity. Now, speed and velocity actually mean the same thing. It actually is the distance covered in a specific time. Is the distance covered? Distance covered in a specific time. But the difference between speed and velocity is that velocity specifies a direction. So if you are saying that this car is moving at 55 kilometers per hour. This is the speed of this car. The speed of this car, if you say it's moving at 55 kilometers per hour. But then if you say that this car is moving at 55 kilometers per hour due east, this is now velocity. Or 55 kilometers per hour due north, or 55 kilometers to the right, or 55 kilometers to the left. This is velocity. So the difference between speed and velocity is that velocity specifies a given direction. So now a recap of what we have done today. We have looked at an overview of scalars and vectors. What are scalar quantities? They are quantities that have magnitude but no direction. Scalar quantities can be completely described, can be completely explained, they can make sense when you specify their magnitude alone. But vector quantities, on the other hand, do not make sense unless you specify the magnitude and the direction. So we can say that vector quantities need magnitude and direction to make sense. So we looked at a few examples of scalar and vector quantities, and we have learned the key difference between distance and displacement, the difference between mass and weight, and the difference between speed and velocity. Thank you so much for watching this video. Please, if you've not yet subscribed,